In this unit, we will work with expressions called polynomials. In this lesson, we will define polynomials and learn how to add or subtract them. On this page, there are a list of key vocabulary terms that you will encounter during today's presentation. Be sure to write their definitions down as you meet them. So let's begin with our question. What is a polynomial? Well, a polynomial is a sum of monomials or a single monomial. Well, in order to understand this definition, we need to know what a monomial is. Well, a monomial is a simple expression that's composed of a number, a variable, or the product of a number or variable. It's important to remember that each exponent that's shown in the expression must be a whole number. Let's look at several examples of monomials. In our first example, it is composed of a single variable x with an exponent of 3. Now, since we are working with polynomials, the exponents are referred to as degrees. So we would say that this is a third degree monomial. Our second example of a monomial is composed of a numerical factor 1/3, the variable b, and the exponent of 2. So we would refer to this as a second degree monomial. Our third example is composed of a numerical factor 2.5, the variable a, the variable x, with an exponent of 2. When this occurs, the degree is the sum of the exponents in the expression. So we would refer to this as a third degree monomial. Now that we have looked at several examples of monomials, I would like you to identify in your notes the expressions that are not monomials. Be sure to refer back to our definition of what a monomial is before you make your selection. Now let's take a look at an example of a polynomial. This polynomial is composed of two monomials, 4x squared and -2. We call it a binomial because it has two terms. The 4 is referred to as the leading coefficient because it is the coefficient of the term with the greatest degree. Our second example is composed of 3 monomials, so we would call it a trinomial. And the leading coefficient of our polynomial is the 7 because it is the coefficient of the term with the greatest degree. Now let's simplify a trinomial. To do this, we simply identify and combine the like terms. Remember, like terms have the same variable raised to the same power. In this polynomial, we see that the first term and the last term are like terms. So we combine the coefficients using the distributive property. This yields a simplified result of 10x plus 7y. And this expression is simplified because there are no longer any like terms remaining in our polynomial. This expression is slightly more complicated, but we are going to follow the same pattern. We're going to identify and combine the like terms. So the first term of each polynomial is considered a like term. We also see that the -2y cubed and the 3y cubed are like terms, so we can combine those two. Now we have two terms that we have not used because they are not like terms, so we simply write these terms on the end of our expression. Then we follow the order of operations to simplify the expression. In our final example, we are going to subtract two binomials. Now, subtracting polynomials is exactly like subtracting real numbers. We simply add the opposite of the number. So in this example, we are going to add the opposite of each term in the second polynomial. This yields 2x minus 5 plus the opposite of x plus 2. Now we identify and combine like terms. 2x and -1x. And the constants -5 and +2 can be combined as well. We follow the order of operations to simplify the expression. Now let's review. We've learned how to classify polynomials by the number of terms. We've learned how to identify the leading coefficient of a polynomial. And we've learned how to add and subtract polynomials. On this page, I have 3 items that I would like you to answer in your notes. Make sure you bring these answers to class tomorrow so that we can review them and check your understanding of the lesson.